I hope everybody is connected back. I think some people have left. Okay, anyways. Um, okay. Uh, there's a request to explain why snakes and ladders not to be considered. I'll explain that. In fact, I was explaining that itself. Uh, if I give you I'll put you the next case study, and then you will understand why snakes and ladders are not required in this case. Right? So this was the one that we were discussing, and we came up with this solution that dice, players, board, and coin are the ones. Right? Um, let's try this one. Now it says, okay, I'll wait for some people. The session ended abruptly. They might be willing to join again. Right? So by the time you consider this particular case study, the others will also join. Right? So this case study says that consider a configurable version of snakes and ladders. Right? So this is a configurable version of snakes and ladders game. One of the player, right? We do not know which player at present, but one of the player can configure the number and position of snakes and ladders on the board, right? The game is then played in the usual manner. You need to identify the real world objects that would be required to model this particular system. Right? Now I can still see a lot of people sending messages as to what will be the real world objects, but I will take 2 minutes to take up those answers. I could see more people joining in. Sorry for the abrupt disconnection. So that was some issue with the internet. Okay. And apart from the expected answers, I could see some other unrelated chat messages also going on, but I'll ignore them. So we know that in this case, okay, sorry, it's yellow, so let me just change the color. So we know in this case, we will definitely have a dice, we will definitely have player, and we'll definitely have board, and we'll definitely have coin, right? But additionally, in this case, we'll have snake and we'll have a ladder, right? Now, from the question itself, you can make out that why in this case we have snakes and ladders, and why in the previous case we did not consider snakes and ladders, although they being nouns as well, right? So the way we say that they were so earlier we always used to say that use the nouns to identify the domain objects, but then every noun is not the right candidate to be entered as a domain object, right? In the previous case, snake and ladders do not make themselves the domain concepts, but in this case, the snakes and ladders make themselves to be eligible for being considered as real world objects because they are configurable, right? They are something that can be configured by a player before the game starts. And in this case, every snake will have its own attributes, and that would be the position of the tail as well as the mouth, right? Every ladder will have its own attributes which is the position of its start and the ending point, right? So in this case, the snakes and ladders, because they exhibit certain attributes which are of importance, which have their certain attributes, which have certain behavior, and that is the reason snakes and ladders are considered to be as important domain concepts. Right? I could see people typing yes because they can be configured. Should number also be considered? It is just not the reason. It is one of the reasons, yes, that because they can be configured, they exhibit certain state, they exhibit certain characteristics, they play an important role now in this particular case study, that we consider them as important domain concepts in while analyzing this particular case study, whereas they were not so important because they were static, right? The snakes, the board was not configurable. It's a static board, right? The way you buy a snakes and ladders board, it is static, right? And it remains that way throughout your life. Whereas so is not the case in this particular scenario, where it says that your snakes and ladders can be configured, right? So they have important characteristics, they have important attributes in this particular scenario, and hence they make themselves to the domain concept. Okay, it says one of you have questions that the domain concepts are not the design concepts. I do not say that. All the domain concepts reach the the design of the system, right? So all the domain concepts make themselves to the design level, but at the design level there might be additional software objects that may be added in order to implement the system, right? And that is the reason why some people came up with the idea of a scoreboard, right? So that scoreboard is actually a fabricated software concept which enters your design diagram, or which is usually called in the form in UML as the class diagram, right? It differs from the domain model. The domain model talks about the real world objects, and the design diagram talks about the software objects. But even while identifying the real world objects, or which are more precisely called in the domain model, the domain objects, you have to be really careful in identifying whether these real world objects even do make themselves an eligible candidate for the domain model or not, right? So it is not simply picking up the nouns and moving them ahead. Okay, there's a question, snakes and ladders can be placed at any position. Yes, snakes and ladders can be placed at any location, right? It is configurable during the start of the game itself. So in later versions of this particular case study, which is more elaborate, highly elaborate, you will find that there is some concept called as a game controller. So one of the player is designated as the game controller, and he is responsible for configuring the snakes and ladders on the board and then playing the game, right? So but to have, starting with this particular version of the case study, we know that since snakes and ladders exhibit certain attributes and behavior, they are eligible for being identified as important domain concepts. Okay, I see the almost the same questions coming up in the chat, so I'm not repeating it. Why we need a dice and a coin? Definitely we need a dice and a coin because we are playing snakes and ladders game in the usual manner, right? This case study only elaborates on how the board is being configurable. The rest of the game is played using dice and coins. So there are coins and there are dice that will be rolled on. Okay, sorry. So somebody has written that there is no mention of dice and coin, right? So I did not intend to replicate what is written in the previous slide, but it is there, right? So dice and coins are there. The game is then played in the usual manner by players using coins and dice. Whoever makes it to the crosses the hundredth number first is the winner, right? I think that's it for the snakes and the ladders. Okay, so there is another question. That's a good question. And Webber says that a snake cannot be put at the 100th position as then nobody will ever win. You are very right, Webber, but that's an implementation issue that will not be reflected in the analysis model. Right? So this is a issue which will be taken care at the implementation level. The uh, when you're configuring the snakes and the ladders at that time, there has to be a check that the mouth of a snake is not at the 100th position and no ladder leads you to directly to 100, right? That is the usual scenario that we have, right? You can change it as this is your snakes and ladders game, but of course you cannot put any snake on the mouth of the 100th position, right? But this is always uh, this is something that is a implementation issue. It does not make itself uh, to the domain concept. Okay, so another question which says that board has, I missed the question. Board is a 10 by 10 matrix. Yes, definitely it's a 10 by 10 matrix. I did not understand the question. Board is a 10 by 10 matrix and it is simply drawn, right? So board now loses the the idea or the concept that it had in the previous case study. So in the previous case study, the board was something that was having a 10 by 10 matrix along with the snakes and ladders drawn on it, right? But in this case, the board loses that knowledge of uh, the placement of the snakes and ladders, right? So that knowledge of where each snake is and where each ladder is now encapsulated in individual snakes and ladders object. Although board will be able to uh, access the snakes and ladders objects and query them for that information, definitely yes, but now that knowledge of where a snake is or where a ladder is now resides with the individual snakes and ladders object, right? I think I've made myself clear. I think enough of snakes and ladders. We can post more discussions on the forum, right? What I'll do is that I will pick up the complete case study that I have for the snakes and ladders, and I will post that on the forum, and then we can have more discussion on it, so that will be good. Let us move ahead to the next question that I have. So I'll just clear all this. Okay, and the answer in this case was dice, player, board, and coin that we all agreed to, but snakes and ladders, I think not all agreed to, right? But these will be there because they are an important domain object in this case because they have certain attributes and exhibit certain behavior, right? Now I'll take you to a different kind of a case study. Too much of snakes and ladders now. Uh, okay, this is stack of numbers, right? So you have to implement a stack that would be able to store integer numbers. Identify the real-world objects that would be required to model this system. Right, so you'll have to identify the real-world objects that would be required to model this system. Okay, so I have answers coming in. There is no real-world object. Stack, none, numbers, nodes. Okay, top pointer, storage size, arrays. It doesn't talk about arrays or a linked list anywhere. Okay, so one common answer is stack. Right, so everybody says that there is one, not everybody, so I would say 50% of you are saying that there is a stack, right? Whereas others say there is none. No, that's not right. It is not none, right? There is definitely one real world object which is a stack, right? And then we need a discussion on whether a number or an integer is a real world object, and what else is there? Arrays are there, and I thank goodness nobody said linked list, but then somebody would be thinking that there is a linked list. And then, oh my god, there is a plate. I will not put that. So somebody says there's a plate. There's no plate. And then there is somebody says top of stack. And then there's somebody saying the size of stack. Right? So that's the total answers that we have. We know that stack exhibits a certain kind of a behavior, right? So every stack has a top of the stack, right? Very true. And if the stack is implemented using an array, then we will definitely have a size of the stack, right? But if the stack is implemented using a linked list, we may not even have the top of the stack, right? But when we are saying that you need to implement a stack that would be able to store integers, the only real world object in this case is a stack. Top of the stack, size of the stack are all the attributes of the stack domain concept. Whether it's implemented using an array or it is implemented using a linked list or there is some other implementation of the stack, we are not concerned. At this particular time, when you are carrying out an object-oriented analysis of a given system, it is only the perception of what my real world object will be, which is the most important domain concept that I will have in this particular case, right? And in this case, it is only the stack. right? Some of you might not be convinced, some of you might be convinced. Okay, I'll take you to the next question so that we are more clear about this, right? Stack has a behavior which is a push and a pop, right? So at the time when we study an abstract data structure which is a stack, we are told that it has an attribute which is the top of the stack, and it has a behavior which is push and pop, right? Push, with the help of push, you push onto a stack. With the help of pop, you pop out from the stack, right? Actually, it is irrespective of what you are pushing or popping, the behavior of a stack remains the same, right? But yes, of course, at the implementation level, it becomes important to understand what you are pushing or popping onto the stack, right? And there might be times that even before implementation level, there is a concern that you have to understand what you are pushing or popping onto the stack. Okay, to make myself more clear, I will take you to the next slide, to the next question. So the answer to this is a stack, right? Now let's do this one. Now you have to provide a solution for a stack that would be able to store a binary search tree. Okay, and each BST has a node which has some data, right? You have to identify the domain concept, right? So there is a stack on which I can push a BST, a complete BST. I'm not talking about any linked list, any array, how the BST is implemented. That is irrespective. That is not my point of concern at this point, right? The issue is that I am able to push onto a stack a binary search tree, right? Okay, I can see answers coming onto the chat, and I think all of you have it right as of now. So there is a stack domain concept, there is a BST domain concept, and there is a node domain concept, right? Now again, one question. Some people are putting only stack and nodes and no BST, right? Because BST has nodes, so why do we need a BST? Right, BST is not a domain concept of my concern. I will have stacks, and stacks have nodes being pushed onto it. No, stacks don't have nodes being pushed onto it. Stacks have BST being pushed onto it, right? And every BST is comprising of nodes, right? And these nodes join together based on certain properties to form a BST, right? So we cannot say that we do not have a BST domain class. BST domain class has important attributes, properties, and behaviors which it depicts. It in turn comprises of nodes, right? So we cannot say that BST is not required. BST is also required and nodes are also required, right? I will not say that nodes are not required, because if I would have mentioned that BST only consists of numeric data, that is not what is mentioned here, right? So the BST nodes, they consist of certain numeric data as well as some links, right? So that is what we all know. So BST consists of specialized nodes. So we cannot leave out the nodes here, right? Okay, few questions coming in. but we are implementing a stack and not a BST. That is true. Okay, so there is one question which says that why number is not a real-time object in this particular case, in the previous one, right? So when we were pushing numbers, simple numbers onto the stack, we did not consider numbers to be a domain object because effectively they're always numbers or characters, they're always effectively considered to be the basic data types, right? And this is the reason why we did not consider numbers to be an important domain concept in the previous example. Whereas in this one we say that BST is supposed to be a important domain concept that we need to consider in this particular case, because BST is not something that is um, existing as a basic data type, right? So it's the moment we say basic data types, we talk about numbers, characters, or maybe integers, positive, negatives, right? So when we have a consideration of only numbers, we do not effectively put them into a real world object, right? But in this case, when the concern was that a BST has to be pushed onto a stack, then a BST is a more sophisticated real world object, right? That would be uh, required to be created, that will have its own attributes and would be pushed onto the stack. Okay, right. A few more questions which are almost related, and then they say that neither a stack nor a BST is a real world object, right? Um, when we say real world object, so it is not actually a real world object that you can see, right? So more again and again, if you notice, I have been using a word called as domain concept, right? So it is not exactly a real world object that we would say is translating into a domain concept, or is what our point of concern is, right? But a domain concept is more or less a conceptual consideration that is existing in a case study that we need to capture and put it into a domain model, right? So it could be a real world object, but it could be a conceptual object which is existing for that particular case study, right? You can immediately bring out from the case study given that these will be the kind of uh, domain concepts that will make a that will need to be captured, right? uh, okay, there are more questions coming in. Okay, the question of BST seem to be really I would say complicated, right? So you're saying that we have a BST, why are we pushing it onto a stack? We were implementing stack, how does the BST come in, right? The idea of adding this particular kind of a case study was that just do not bother yourself as to how a BST is implemented, right? The whole idea is that some important domain concept is getting pushed onto the stack, right? And that domain concept has to be captured. Whether it's a BST or it's a plate, that is not a problem, right? Nowhere in the course will I ask you to implement a BST, right? I will always say there is a BST object, push it onto the stack. You have the ready-made object with you. Never I will ask you to write the implementation of a BST and write an implementation of a stack and push the BST on stack, right? It is just a case study. It is just at a case study level that I'm trying to explain that given a case study at the analysis level, you need to identify the domain concept. Don't bogged up with uh, the concept of a BST coming in, right? It is just I could have put plates here. So there's a stack of in which I have to push on plates. There's a stack in which I have to push on books. There's a stack on which I have to push on cups, right? That would have been a more easier understanding. Then you would be really fine saying that I have a stack, I have a plate, which is a domain concept. I have a stack, I have a book, which is a domain concept. And I have a stack and I have a cup, which is a domain concept, right? The only issue which a BST brings in is that it's a domain concept which is having important attribute, it exhibits states, it has its methods, and hence an important domain concept which needs to be captured. Right, I think I'm done on this slide. I'll clear the annotations and then see what was the answer that I had here. So of course there was a stack and a tree or a BST, this is the same thing, and a node domain concept, right? I would further complicate this question and move you to the next slide, which says you have to implement a stack that would be able to store the following: a BST, which consists of 3 nodes, a graph, which consists of graph nodes, and a forest, which consists of connected graphs. Right? You need to identify. So I would remove the word here, real world object, so that is leading to a bit of confusion. And let us put here, identify the domain concepts. I think everybody is there with me now, right? So there is no point of question. Everybody knows what all the domain objects that are there. So there is a stack, right? There is a BST, or it could be a tree, and every BST has a node, so a tree node, right? So it says each BST consists of 3 nodes. So I would say there are 3 nodes. Then there is a domain concept which is graph, and then there are sophisticated nodes which are called graph nodes, because every graph, it says, is made up of graph nodes, and there is a forest, right? And since forest is made up of graphs, so there is no need of any other domain concept. Right? Let me just see the chat, what everybody is having. I think more or less everybody is close to this, 90% of you. Okay, so I think I have achieved what I wanted to achieve today, right? Everybody would now be able to identify the various uh, domain concepts given a case study, right? We will have a quick look at this particular aspect when we will go and draw the domain model. That would be later, late in subsequent second or third lecture, right? But effectively, with this idea, we all know that what a we looking for given a case study, right? So it is, there's no hurry to go for implementation. There is no hurry to go for UML diagramming, right? So some of you might be knowing the aspects of UML as well. So there is no hurry, or there's no rush for that. Take your time step by step, right? So it is very important that when you are having a given a case study, you have to do an analysis and design of this. The steps are very important. You must go by step, and then you should move ahead and then decide what is my next step. Every step evaluate it 10 times and then move ahead. If you move this way, you will surely be reaching what you need to implement. Okay, I'll take up 2-3 more questions which have come up. Node can have two types like tree nodes and graph nodes. So why separate tree nodes and graph nodes? I have intentionally written in this case study that there are tree nodes and graph nodes so as to distinguish between tree nodes and graph nodes separately. The question, Yogesh, you're asking this because in the back of your mind you're having that there is something called as inheritance hierarchy that exists, right? So you will have a main node and then you will inherit tree nodes and probably graph nodes from it. You are very true. You will do this when you will draw the class diagram for this, if only you find that both these nodes have something in common, right? But that is at the level of class diagram that you find out the inheritance relationship. At the analysis level, we are sticking only to what is the, of course, the nouns that are there, right, without the aim of fabricating any additional word, right? So we will not separate out a domain concept as node as of now. You will keep it as tree node and graph nodes. Maybe later in your design you may find it useful to have that inheritance hierarchy. You can definitely have that. Okay, so that was, I think, most of you have asked this kind of a question. Why not only one node uh, domain concept, and why two different? So I think I have answered that. Okay, there was a lot more that I had intended to cover in this particular lecture, which I was not. But anyways, we have so many more lectures to come. Uh, okay, so this was the answer that I had, right? And this is what we also discussed. So just to summarize, we were able to effectively do an object-oriented analysis in today's lecture, and we were able to identify the domain software objects, right? So what I will do, maybe today or tomorrow, I will upload the snakes and ladders case study that I have with me. And the first step is that we will do an analysis model of that. All of you are expected to do an analysis model of that, and we'll probably take up in the next lecture, right? There's a question, do we have a lecture tomorrow? As per the schedule I do not have a lecture tomorrow. If there is a lecture in your schedule tomorrow, I'll have to check that, but you'll get the notification through the eLearn portal, right? Because it does not move on onto a 18 session mode. It is a flipped model, so we'll have only 6 sessions before the mid-semester, right? Okay. Um, I need to skip to the end of the presentation, so I'll just move on to one step ahead, and I just want to put you, okay, I've got the right slide. So this is the plan ahead for lecture 2 and what you are expected to go through. You are expected to go through module 1 of the digital content, which talks about the waterfall model, the unified model, and the agile models, right? So basically, this first module is provided to give you an overview of waterfall and agile models, and it is expected that you already have a knowledge of these models because you're expected to have already done software engineering, right? And so you please go through these particular modules. Uh, Coming to the unified process was something that I was planning to cover today, but since I'm not able to do it, we'll take up in the next lecture, right? So you please go through the complete module 1, unified process as well, so that we quickly move through the unified process as well, right? So unified process is one topic which I will cover in a lecture mode. I do not want to leave it in completely as a self-study mode. So this one topic I will cover on a lecture mode, and then we will quickly move over to use case diagrams. Right, so what you can do is that listen to complete of module 1, and from the module 2 only pick up the use case diagrams module. Right, so I don't think so I will be able to cover more than this in the next lecture. Right, so first half we'll do the unified process, and in the second half we'll take up case studies and draw use case diagrams for these case studies. Right, also if time permits, I will give you a demo of the lab platform which has been set up by Bitsplani. The name of the lab platform is called Platify, and you are expected to uh, explore this platform, make use of this platform in order to do lab assignments or practice assignments for your courses. The idea of this lab platform is that you can access this platform on the cloud and without hassle of installing any software, right? So every course might require a different kind of a software for implementing the labs. So without that hassle of having installing 10 different softwares, you simply need to connect to this platform and do the lab assignments in the cloud space that is provided in the platform, and the platform has all the required tools uploaded on it, right? And in this particular course, we will use star UML, which is already uploaded on the Platify platform, to draw the various use case diagrams. In one of the lectures, I will give you a small demo of the platform, how you can use it, and I will also give you a small demo of the tool star UML. However, it is more of a self work that you will be required to do in this case, and this will be beneficial for you at the time of submission of the assignment. Okay, I think that's it for now. I'll take up 2-3 minutes are there, so I can take up a few questions. You can buy the Larman textbook as of now, and when you get the design patterns book, you can take it that time, because design patterns will definitely come after the mid-semester. The lecture slides are uploaded on the eLearn portal. All of you would be able to access your eLearn portal through a login and a password that you would have got. And on that eLearn portal, you will find on the leftmost side there is a link called My Courses, and then you will get, for a particular course, say for object-oriented analysis design, you will get 2 links. One link which says courseware, and the other link which is actually the course, the current course portal, right? So courseware is where the digital content is uploaded, and the current course portal is where you will be able to access the course handout, the discussion forums, etc. Right? Please connect to each other. make use of the eLearn portal, the discussion forum, and that would be beneficial to you. Even before the start of this lecture, I saw many people who have connected to the eLearn portal and have posted messages about the WhatsApp groups that are existing. You can make use of them, join them, but keep tracking the eLearn portal as well, right? So for me, I mean, your WhatsApp group is what something I'm not going to join, but of course I will be there for further discussions on the eLearn portal. So you can post your discussions on then, and I would be trying to address to those. It is not required to buy the reference books, definitely not. Textbooks will suffice. It's okay. There's a question. Are we going to focus on any specific programming language? Yes, definitely it's going to be Java, but uh, I will not request you to write any program in Java. Most of it, right? Most of the time you will not be required to write any program, but then in order to understand design patterns, you need to understand how the code is written in Java, right? So those who already have a knowledge of Java will definitely benefit. Those who do not have, please try and get a book in handy and go through the same. I think that's it for now. There's so many chat messages. I cannot take up all of them today, right? But I'll close off now and then we can take them offline, right? Sorry for the break that happened, but that's all. The technology that is there, it helps us and it poses problems as well, right? Okay, thank you so much. You will get information about the next lecture from the eLearn portal. Thank you.